we're going to start off by calculating, taking into account our factor of safety. So columns fail when they reach the Euler load. The Euler load is a theoretical maximum load that an initially straight column can support without buckling. So we're going to multiply the load that we need to support by 2.5, and that'll give us 187,500 pound force. We're going to use that as our Euler load later in this problem. The next thing we need to do is to calculate what is called our effective length. So the formula for effective length, that's this L prime, is equal to the theoretical end restraint coefficient times the length of the column. So again, that's our 0.65 times 50 feet, which gives us 32.5 feet. We will need to use inches because all the problem statements are in inches, so we're just going to go ahead and convert to inches now, give us 390 inches for our effective length. So now we're going to pull out the equation for Euler load. So Euler load is noted Fe, and it is equal to pi squared times the modulus of elasticity times the moment of inertia, which is the answer we're after, over the effective length squared. So we're going to go ahead and rearrange this formula so that we can just solve for moment of inertia outright. So we'll pull I equals the effective length squared times the Euler load over pi squared times the modulus of elasticity. We're going to go ahead and plug our values in as the 390 inches that we converted to squared times 187,500 pound force over pi squared times the 30 times 10 to the 6 pound force over inches squared that we said we would use as modulus of elasticity. We're going to plug that into our calculator and we will get 96.32 inches to the fourth. Something I like to do when I'm working with problems is to go back and make sure that my units actually cancel out to get the units of my answer. It's kind of a check to make sure you don't have anything crazy wrong. So we're going to see that pound force does indeed cancel. There's no units with pi, and since this is in the denominator, it'll make inches to the fourth, so we're good on units. So 96.32 is closest to our answer choice C. It's pretty spot on.